Hi, welcome to Math for All, where everyone can learn more about math. I'm Denise, and today our lesson is on how to add and subtract radicals. These irrational dudes, remember that if they're not perfect squares, then they are decimals that never end or repeat. So they don't always behave the way that we think that they should. So let's hit it. First, we'll see when it's legal to add and subtract them. It sounds easy enough, but not so fast. We must learn their rules. We'll take the square root of 6 plus the square root of 19. The temptation is to add 6 plus 19 on the inside for a square root of 25, which you should know is 5. However, this would be illegal. Let me show you how this does not work. We'll use a calculator, and the square root of 6 is about 2.449, and then the square root of 19 is about 4.359. If we add those babies up, we're at 6.808, which is definitely not 5. Now, you can see that we will not just add what is under radicals, so here's the rule. You may only add or subtract like radicals, those that have exactly the same numbers and or letters under the radical sign. Some like radical examples that can be combined would be like the square root of 3 and 4 times the square root of 3, and negative 5 root 7y and 14 root 7y. Unlike radical examples could be the square root of 2 and 2, or 8 root z and 8 root a. This rule can be summarized in algebra language. A root b plus c root b equals a plus c times root b. Basically, you add or subtract the front numbers, or the coefficients, and then leave the radical the same, just like when we add like terms with just variables. 3x plus 4x equals 3 plus 4 times x, which equals 7x. Using this idea, what is negative 4 root 10 plus root 10? Since we have like radicals, we add the front numbers and then let the radical hang out. There's an invisible 1 in front of the root 10. For negative 4 plus 1 equals negative 3. We bring over the root 10 for an answer of negative 3 root 10. Now we'll take this problem. Simplify 3 root 20 minus root 45. It looks like we're at a dead end here because the radicands, which are the numbers under the radicals, are different, and we know that we can't combine them. But don't give up yet. We learned how to simplify radicals, and I have a sneaking suspicion that something may come out of doing just that. We start with factor trees. 20 is 4 times 5, and 4 is 2 times 2. One of those 2's pops out and gets multiplied by the 3 already on the outside, for 6 root 5. Next, 45 is 9 times 5, and 9 is 3 times 3, for a 3 out and a 5 left over for 3 root 5. We won't forget that we're combining these and that we're also subtracting. So 6 minus 3 in front and the root 5 is along for the ride for an answer of 3 root 5. Beautiful. Congrats on learning the details on adding and subtracting radicals. Be sure to remember to simplify those dudes first, and when they have like radicals, add or subtract the front numbers and then leave that radical the same. And finally, remember to keep coming back to learn more about math.